Okay, so we have this function here which we have to solve. It's tan of 3x plus 3 pi equals 1 over root 3, and we're given the domain for x of minus pi to pi. Okay, so we have to solve, so we're going to get x equals something. Okay, and given that we've got a domain with the trig functions, there might be more than one answer, so we might get a whole string of answers there. But broadly, that's what we asked to find the answer to. Now, this is actually pretty simple if we didn't have this 3x plus 3 pi in there. So if I just said tan of a equals 1 over root 3, then you know just from memory that a would give you 30 degrees, or pi over 6. Okay, and if I map this out on our circle here to figure out where tan is, in this case, positive, so we have all sine, tan, and cos. So there's a 30 degrees here. So let's call it pi over 6. We'll stick to radians because the domain here is given in radians. The other place where it's positive is in the third quadrant, so that's another pi over 6 here. So that gives us, what's that, 6 pi over 6 is 180. So 7 pi over 6 is this one here. Okay, so if we were asked to solve that, it's really easy, right? So 30 degrees or 210 degrees, pi over 6, 7 pi over 6. So what a pity that we weren't given that. However, it's pretty straightforward to get from what we're given to this. And essentially we'll come back to this because this is actually what we're going to use to solve it. The only tricky thing is to figure out what our domain is going to be. So let's do it this way. So we've got that x is in the domain minus pi to pi. Okay, that must mean that 3x is in the domain minus 3 pi to 3 pi, because I've just multiplied both endpoints by 3. And that must also mean that 3x plus 3 pi must be in the domain. So now we're adding 3 pi to both endpoints. So that's minus 3 pi plus 3 pi is 0, 0 to 6 pi. Okay, so if we call this 3x plus 3 pi, if we call that a, what we're told is that a has to be in the domain 0 to 6 pi. And now let's go back to this equation here. So now we've got tan a equals 1 over root 3, where a is in the domain 0 to 6 pi. Okay, and now we just figure out what that is. 6 pi is 3 times 2 pi, and 2 pi is one circle, so it's 3 revolutions of the circle. Okay, so 3 revolutions of the circle. We're actually going to end up with 6 answers, because each revolution gives us 2 answers, one in this quadrant here, and the second one here. Then we go around again, and we get another one here, another one here, and answer 5 here, and answer 6 here. So we're just going to go around 3 times. All right, and we just have to figure out what those numbers are. Okay, so we know the first 2 because we figured those out before. So it's pi over 6 or 7 pi over 6. And now we just keep adding 2 pi each time. I guess 2 pi is a full revolution, or let's call that 12 pi over 6. So we're just going to add 12 to each of these numbers. So we get 13 pi over 6. 7 and 12 is 19 pi over 6. Add another 12 to this one, gives us 25 pi over 6. Add 12 to this one here, 19 and 12 is 31 pi over 6. Okay, so that's our answer, almost. The only tricky thing is that we need to convert those back into x's because we've got our answers here in a, and we have to solve it for x. Now we know that a, from what we said here, was 3x plus 3 pi. So if we rearrange it, we get x equals a minus 3 pi over 3. Is that right? Yep. So subtract 3 pi from both sides, divide by 3. Yep, good. Okay, so what we do for each of these now is subtract 3 pi from each of them and divide by 3, and that gives us our answer. So we've got these 6 answers here for a. Subtract 3 pi and divide by 3 from each one. Okay, I think the simplest way to do that is to say that x is a minus, so what are we, over 6? So let's call it 18 pi over 6 divided by 3. So our x's, we just subtract 18 from each one. So that's 1 pi, so we get minus 17 pi over 6, but then divide by 3, so minus 17 pi over 18. This one, 7 minus 18 is minus 11 pi over 18, and so on. So 13 minus 18 is minus 5 pi over 18, 19 minus 18 is 1, so pi. 25 minus 18 is 7. And 31 minus 18 is, what's that? 13. Okay, so that's our answer. And let's just